First of all, many thanks to Juan for inviting me and my colleague Matthew along for this presentation about cloud modeling and about model scalability with GenMyModel. And because we are two, I will present the first half of the presentation, and then my colleague Matthew will continue to the second half and finish up. My name is Blažo Nastov. I have a PhD in computer science and in particular in the domain of model-based systems engineering. And I'm currently a research director at Axellience. My colleague Matthew has also a PhD in computer science in the domain of model-driven engineering, and he's currently a research engineer at Axellience. So before we start, a few words about the company, Axellience. It is basically a spin-off of the French National Research Institute in Computer Science. It was founded in 2012, even though the initial ideas date back to 2008. The founder of Axellience is Alexis Müller, and basically he was a researcher at INRIA. And he was having these ideas in 2008, and that is how he started the company. So between 2012 and 2015, several releases were made, and the final version was released in 2015. And GenMyModel was one of the first cloud modeling platforms back then. Axellience has currently two products: the GenMyModeling platform that supports modeling tools for software development, such as it supports standards such as UML, Archimate, BPMN, and others. And we have another product called Agile Architecture Factory, and this is basically for DevOps. I mean, the goal there is to bridge the gap between architects, operationals, and developers. Just to mention a few numbers, so we currently have, the users have currently built more than 1 million models by using our platforms. We have a bit less than 1 million users, and they come from all around the world. Some of our customers are big corporations like IBM, Amazon, Cisco, Huawei, or Renault, for example. This is the agenda for today's presentation. Just to mention, we don't have a technical presentation. I wasn't aware that we should go into any details like presenting code or some stuff like that. But we have more of a general type presentation, introducing, for example, key features of our platform, what are the requirements to have these features, and so on. So I'll first start with an introduction, then I'll talk about the feature of GenMyModels, and I'm going to talk about cloud modeling, about model collaboration, about scalability with our platform, and about some other feature. And note that the feature that we are going to present are not exhaustive, which means that GenMyModel platform has other features that are not going to be presented here today. And at the end of the presentation, my colleague will conclude. Well, generally, systems are becoming more and more complex. For example, if you compare a mobile phone from back then, like Nokia 3310, with a smartphone of today, let's say like an iPhone, you can see that they're completely different. And I mean that in terms of functionalities, in terms of services, in terms of required performances, and so on. As the difficulty increases, the design of these systems become more and more difficult. And so the design methods must keep up with such continuously increasing complexity. So generally and classically, document-based approaches are becoming more and more obsolete. And engineers are starting to use model-driven approaches. And this is basically because models can be consumed and processed much easier than documents. On the one hand, they have all the general advantages of the digital world. For example, they can be easily stored, they can be sent to other users, they're archived, they're never lost, they can be easily copied, and so on. But in addition to these general advantages, they also provide a better representation for improved understanding. They can be used for verification and validation, for model correctness, and this in turn will improve the confidence of stakeholders that are using models for decision making. Of course, models can be used for automatic generation in order to generate a part of the system we're trying to model, for example. They are also scalable, and at the end of the day, they can reduce the time of the market. So we have some gains like economical, for example. Models are nowadays built and managed by modeling tools. And we have modeling tools for more than 30 years now. But despite being technologically powerful, desktop modeling tools currently on the market are not designed for agile development, and in general, they lack. Our clients has expressed some criticism about such tools. So they are difficult to collaborate, they're complex to use, and they're generally reserved for experts. They have a negative perception by development teams, and this is why developers generally do not use modeling tools. They have, of course, an installation time, and they have to be managed for different upgrades, which is very difficult when deploying such tools in large organization. For example, if you have to install thousands of modeling tools on each different computer in a company. As a solution to this problem, GenMyModel offers a professional cloud modeling environment. It allows exchange and model sharing and real-time editing of this model. So the idea behind it is to collaborate in real time with other architects to share the models in just a click, and in order to have a better understanding of different needs of all the different collaborators. GenMyModel also allows hosting and versioning of models. And when I talk about hosting and versioning, I mean Google Drive-like hosting and versioning. So the idea behind it is to archive the model so that they are never lost. And GenMyModel also proposes a code generation, which is customizable in order to meet the different needs of different collaborators. Right, so the key feature of GenMyModel. Here's an overview of the key features. So we are going to talk about cloud modeling, about code generation, about model scalability, collaboration, of course, model versioning, and traceability. Well, basically, cloud modeling is the combination of modeling and cloud computing. So we cannot talk about cloud modeling before explaining, for example, what cloud computing is. And basically, cloud computing enables company to consume a resource as a utility rather than having to build and maintain an in-house infrastructure. If you think about it, it's just like, for example, electricity. So you don't have to build a power plant and a system for electricity transportation in order to use the electricity at your home, but you only pay for the resources that you're using, in this case being electricity. Cloud computing provides a couple of advantages, and here note that the advantages I'm presenting are not exhaustive, meaning that there are also many other advantages that I'm not going to state. So the first one being elasticity, the ability to scale up or down quickly and easily in order to meet demand. Users can, they pay only for what they use, and they are not paying for what they are not using. So we have a granularity level depending on the use. And the third advantage being self-service, meaning that you don't need IT administrator to provision and manage different resources. So everything is done for you and prepared for you. As I previously said, cloud modeling is the combination of cloud computing and modeling. So the idea behind it is to combine the technological power of the classical modeling tools with the advantages of cloud computing. And the idea behind it is in order to improve some limitation. For example, they're simple to use because ergonomy is a key factor. And this is especially true when we're talking about web application. I mean, if the application is not ergonomically well designed, well, then users are not going to use it. I mean, they're automatically will continue to another website. They're simpler to maintain because you don't need a maintenance administrators. Of course, there is a no installation time. Collaboration is native as for the majority of the web application, and there is a centralized repository, model repository, so that models are never lost. In order to build cloud modeling, you need to respect several requirements that comes from the modeling perspective. So the first one being conformity to standards. And I mean, nowadays there are a lot of cloud modeling editors that are not basically cloud modeling editors. They are simply cloud drawing editors. And this is because they do not provide an underlying structure or an underlying model behind the representation. It's simply a photo of the model. The other requirement is being complete to standards, and by this I mean the ability to cover all the concepts, all the constraints, and notations and diagrams that are defined by different standards. And last but not least, being similar to classical tools. And this requirement is very important because nowadays the majority of modeling tools users are using the desktop modeling tools. So when they make the transition from desktop into cloud modeling platform, these transitions need to be aced in some or another way. And for example, being similar to the classical tools, for us, it's an advantage. But this is a tricky one because, as I stated previously, classical desktop tools tend not to be ergonomical. And here we try to make a cloud modeling platform where ergonomy is a key factor. This is our platform. So when you create an account, you go to the dashboard, and you can use the dashboard to create models, to open up these models and modify them, to invite different users. And there are also a couple of other features that we're not going to talk about today. And when you open the model, you have basically an editor in your browser, and you can use this editor to create different instances. For example, here I have an Archimate editor, and what you see is a diagram for the Archimate editor. The second feature is about code and document generation. And the idea behind this is, instead of manually writing everything, I mean the code or the document, the idea is to reuse existing models in order to generate either the documentation for the system, because I mean sometimes document models are used as a design and as a means for documentation, but also this is used to generate parts of the system. And when doing this, we have important time gains and important productivity gains. Again, for the generation, there are a couple of requirements. So the first one being the generation templates. I mean, you have to provide a database of different templates that users can use in order to generate their code. And here I mean pre-designed templates that can be directly used. For example, let's say you have an UML model. A basic template would be a transformation from UML into Java code, for example, or C code. The other requirement is about customization, the ability to customize the template in order to adapt them to the needs of the customers or the modelers. The third requirement here is about incremental generation, and we've talked about it, I mean, in the first presentation about this. So this is the ability to regenerate a part of the model. And in addition to that, we have added, for example, the ability to relate such incremental generation with a Git repository, so that the Git repository is automatically updated when you generate the code. And last but not least, the preview requirement, which allows users to view the code or view the documentation before they generate it. So this is an example. As you have seen, this is the main editor where you can edit the models, but we also have views for code generation. And so here you see a script for code generation that has different functions like auto-completion and so on. And for example, this is a result of documentation that is generated based on the Archimate model that I have just shown you. Right, so we are coming to the second part of the presentation, and this is where my colleague Mathieu Laurent will continue.
Okay, thank you, Melo. Okay, do you see my screen, my presentation?
Yes.
Yes, thank you. Okay, so now I'm going to introduce the other key features of GenMyModel. The first one concerns model scalability. Just a quick reminder about it. Model scalability is a property of a system to maintain its level of performance when storing and managing very large models, or VLM. We will use this acronym in the rest of the presentation. Generally, the benefits are the following ones. A time gain, because with model scalability, you access to VLM without a loss of performance. Productivity gain, because VLM modification are done without a performance loss. And resource gain, due to the fact the resources not allocated to VLM handling are used for something else. Concerning model scalability, there are different requirements. The first one is about model loading, that is to say, effectively display and navigate into VLM content. The other requirement concerns model artifact search, the possibility to efficiently search artifacts, for instance, by name, meta type, or stereotype. This is what we are implementing in our platform, in the GenMyModel platform. We face different problems. The first one was about efficient model access. That is to say, be able to access to any targeted VLM part without a performance loss. For this, we are implementing the lazy loading mechanism. That is to say, modelers are able to access, to load model parts only when access is required. The second point was about VLM understanding and browsing. The possibility to understand and navigate easily between the various parts composing a VLM. For this, we are provided a mechanism which allows users to split, to fragment these models, these very large models. We call these parts submodels. And here we take advantage of the first point concerning lazy loading. So because you can lazy load this part. System models form a model hierarchy. So this hierarchy allow to understand and browse easily in very large model. The third question was about effective model search. That is to say, be able to find a model element in VLMs at the same efficiency than in other models. For this, we have implemented a model element indexation on each artifact, on each model element creation or update. I talked about this earlier. In GenMyModel, users can search model element by their name, type, or even stereotypes using this mechanism. Another key features of the GenMyModel platform is collaborative modeling. Collaborative modeling allows users to build models collaboratively. So for this, you need to have different governance rules, access rules. But just before continuing to present this, just a quick reminder about the two kinds of collaboration you can have. The first one is the asynchronous collaboration, where interactions are time shifted. And the second one is the synchronous collaboration, where everyone interacts in real time, for instance, like in Google Doc. Some years ago, research at the University of Lille, a PhD student made his thesis about collaborative modeling. This thesis was titled Toward Efficient Collaboration for Modeling Tools. It was Michel Dirix. So concerning collaborative modeling, there are different requirements. The first one is access management, which is a key factor for effective collaboration. For this, in GenMyModel, we have defined some mechanism about team management. Users can assign role to other users. We have defined also a custom access management, for instance, access to particular model parts. The second requirement was about awareness. When we say awareness, it's the fact to be aware of the work of collaborators when they enter or exit the environment, and even when they are making some modifications in the models. The third requirement is agility, which means providing the means for agile modeling via collaboration. For this, in our platform, we provide some mechanism to allow users to make to-do lists, to assign a task to other users, and even to use and to define and use bidirectional links between these tasks and model elements. We face different problems concerning collaborative modeling. The first one was about synchronous collaboration latency. More precisely, the question was, can we eliminate the latency as in video games? For instance, using rollback mechanisms. The second problem was about undo and redo action. Can users see actions canceled or redone by others without any conflicts? And the third problem concerns general access management versus custom access management. And when we are talking about general access management, it's the fact to consider to not consider any type of users and just to lock a model for when any user modify a model. And custom access management is the possibility to define different kind of access. And the question was, can a general or custom access management be used as a model? Another key feature of the GenMyModel platform was about model versioning. Again, just a quick reminder about it. Model versioning is the creation and management of multiple releases of a model, all of which have the same general function, but are improved, upgraded, or customized. Generally, we consider for model versioning the following advantages. We can compare model versions, identify the differences, roll back also modifications, and keep particular versions. Concerning these features, there are different requirements. The first one is the possibility to compare a version and identify the differences, like in EMF compare, for instance, and the possibility to graphically represent conflicts on models. The second requirement is a partial versioning, that is to say, be able to version a part of a model. And the first one concerns alignment, where we mean here alignment with other versioning system, aligned with the versioning of standard exists. For instance, we can talk about the use of UML operators, for instance, the merge one. Here we have a screenshot of our platform concerning version management. So you can create a different version for your current project, your current model. You can define a different. You can restore this version, of course, and you can view them. Another key feature is model traceability. Model traceability is a process which allows to record the design process of a model during its life cycle. In general, we consider the following benefits. We can keep track of all changes in the model by any collaborator, consult changes in a particular approach in time on restore model, or a copy of model to a particular point. There are different requirements for this feature. Simplicity. We mean by this an intelligent representation and management of recorded changes. We have implemented a video player-like solution for changes management with the possibility to play, pause, go into the previous change, and so on. Another requirement concerns version traceability, which is related to another feature I've introduced before, which is the versioning. In our platform, you are able to tag new versions, define them as major, minor, or fixes. You are able also to animate changes for particular versions. Two other requirements. Another one is branches traceability, which is related to asynchronous collaboration. It will be interesting to be able to animate several branches, display changes from branch creation until merging. Another one concerns filtered traceability, that is to say, only display particular modifications, display model structure modification, or even modification on one element. So here you are the player I've talked about. So you have a model, and you have the possibility to display the changes, the evolutions of the model using the plays, going to next change, etc. You have also the possibility to download a particular version for more points in the history of the model evolution. So to conclude, we have presented different GenMyModel feature, and we can see there are some crossbreeding between the lowcomote objectives and these features, notably the following ones: the clone modeling, where we use models coming from a large number of users, and which allow to install, maintain, and which facilitate the use of modeling platform and its artifacts. Model Scalability, which allow to manage very large model, and where we have a gain in time, productivity, and resources. And another key feature, which is the code generation, allowing to produce software application part for models, and where we have a gain in time and productivity. We have different perspectives. Currently, we continue working on the discussed points and also on other questions like interoperability, model verification and validation. We also use our features for the modeling of critical infrastructures and assessment of their resiliency. For this, we have a PhD student which work on digital mockup and digital twin, notably. And we are working also on a pioneer project, a French project, with the concept of cloud modeling and resilience assessment, and also 3D reality capture, notably augmented reality and virtual reality. So thank you for your attention, and if you have any questions, don't hesitate.
Thanks, excellent. Do you have any question? Do you have any question you would like to ask? Well, in the meantime, maybe I can start. Yeah, it was so nice to see all these features and how well they integrate to each other. I was thinking, I think it would be a question for Blaso. So it was not clear to me whether the set of modeling languages that are supported by GenMyModel is fixed, or I, as a user, can define a new modeling language, maybe through a meta model, and then define my own models.
This is a very good question because it joins with the ANR project. First of all, at the beginning, I mean, the platform had a fixed number of languages. But then when we started the research project, and because we have different partners from academia, they wanted to design DSL-like languages. And these were languages specifically for the design of critical infrastructure. For example, they wanted to have a language for the design of the resilience properties, another for the design of the context, and so on. But they didn't want to use the different standards. I mean, the general standards that we propose. And in order to resolve this problem, we have made a solution based on UML profiles. And with this solution, I mean, we can either extend UML and adapt it to different needs, but also we have extended UML profiles, and now they're adaptable to any of our standards. For example, you can use UML profiles to adapt a version of EMF, to adapt a version of UML, and so on. And by that, by using this mechanism, users are able to define their a whole new language, for example.
Yeah, cool. Any other question? All right, so I have more questions from my side. So you have mentioned that you make available code generators, and then you can customize those and so on. But one thing that normally engineers do in model-driven solutions, for example, within Eclipse, is to apply model transformations, to generate a model from another one and so on. Do you plan? Do you support that? For example, transformations written in APL or things like that? Or do you have plans for doing that? Would that be interesting for your tool?
In terms of model-to-model transformation, for example, we have a couple of examples. For example, being able to transform, let's say, BPMN model into a BPMN standard or into another type of standard, because some of the standards have different underlying representations, and based on that, we are able to define to do this type of model-to-model transformation. But just know that what we have now, it's fixed. I mean, we don't have editable or customizable model-to-model transformation mechanisms. Anyway, you can use the model-to-text mechanism in order to transform your model into a specific formalism, and then you can import it back into your modeling platform, for example, and that can be done.
Mm-hmm. Yeah, cool. I would have another question, but concerning scalability. So perhaps this is more for Matthew, because you have mentioned something quite interesting, which is you split the models, creating kind of hierarchies. I think you mentioned, but I was interested in knowing whether this is done explicitly by the user when creating the model, or there is somehow a strategy for fragmenting the model by the engine, or how this is done in practice.
Okay. Currently, this is done manually by the users. They decide to split the model. We haven't any algorithm or mechanism allowing to split automatically a model. But yes, I think in the future it will be interesting to do this. But we need to study more this kind of thing, of course.
But then is this something that this would be transparent to, for example, the code generator? So could the code generator work on the structure of fragmented models?
I can complete the response to Matthew. We have a client that were using that was using Spark systems, and they had a model with I think it was 9,000 or 8,000 diagrams, and it was several gigabytes model. And the problem with that was when we have imported it directly into the modeling tool, the tool has crashed. So we had to work on scalability and how to divide this model and so on. So in this case, we have jointly worked with the experts, with the modeling experts of that company, and they gave us the main rules that were used to split the model. And when I say split the model, I do not, because we have two types of splitting. You can either divide the model into several submodels, or you can basically use EMF proxies, for example, in order to reference different types of the model. But currently we don't have a mechanism that works for everybody, because we believe that the splitting of the model should be jointly done with the modeling teams. They are going to give you the rules how to split, how they want the model to be split, and then this mechanism should. Currently we manually write the code that is going to split the model, but maybe we can do, for example, an automatic mechanism that uses such rules, for example.
Yeah, that would be very interesting.
But there are a couple of questions related to scalability. For example, how, as you mentioned, how do you divide the model, and then again when to load, for example, different parts of the model. If the user opens the model, should you load some part or not, etc.
Yeah, that's cool. Yeah, I think Massimo has another question.
Yes, it's Massimo. My question is about portability. So the question is portability important for GenMyModels, in the sense which artifacts can I take out of GenMyModels and use in another environment, and then take them back in GenMyModels when I want to? I suppose some EMF models are, but what are all the artifacts that I can actually reuse somewhere else? And that's an issue for your users.
This is what we mean when we stated the interoperability line. By interoperability, we mean the ability of our editor to be exported, models of our editor to be exported or imported in another editors. And of course, we do this, but only for standardized models. For example, if you take a BPMN model, there is a strict specification about the structure of the model, but also about the representation of the model. So in this case, we can export the model into the specific in the specific form, and then this form can be imported by any tool that need to use the model. And of course, if the second or the third party tool has export mechanism, I mean, you're going to import the model, then you're going to edit it. And if this tool has an export mechanism, then you can, of course, export the model and import it back into our tool. But there is another also type of interoperability, and we are currently working on it. And this is the ability to relate together desktop modeling tools and cloud modeling tools. For example, let's say that you have 10 users that are using Eclipse on desktop, and then you have 15 users that are using the cloud platform. And the problem here were how can they all collaborate on the same model, for example, and we are currently working on this problematic.
And let's say in a world where cloud modeling is standard, you would have, I suppose, also portability with Theia, and so user could use different cloud editors for editing the same models. Is it?
Yes, of course. For example, let's say you choose another BPMN in the cloud editor, for example. And of course, the majority of this editor would support import, will have, I mean, import functions. And in this case, you can export all the models of the GenMyModel platform in JSON form or in XML form, or in the specific form that is required by the standard, for example, and you can import them back into the third-party platform. So yeah, this can be done. Maybe.
Okay, thank you.
Okay. Any other question you would like to ask? All right, then if not, thanks a lot to both of you. I think it was very, very nice especially for the ESRs, because your tool touches many functionalities that are somehow very relevant to our ESR. So I'm sure they have appreciated that.
Thank you for the opportunity you have given us.
Perfect.
Thank you.